Quiz 1, question 4. The cortex has control over the spinal cord, and when it is damaged, hyperreflexia ensues. Which theory of motor control would suggest this? The answer is the hierarchical model, and if you just really think about what that word hierarchy means, it should take you to the right answer. Because hierarchy means that there's this top-down approach. You think of the queen and king being over the prince and princess, who are over the peasants, so to speak. Well, in the hierarchy theory of motor control, it's the cortex that is like the king and the queen. It's the mothership, and it controls everything below it. Now, this is not necessarily true. Okay, we know different now. There is not a hierarchy in the central nervous system. There's a lot of parallel communications between the different structures of the central nervous system. But, back 80, 90 years ago, we believed that there was this hierarchy and that the cortex had control over everything below it. So it controlled the brainstem and it controlled the spinal cord. And as you know, all monosynaptic reflexes go through the spinal cord. And it's believed that the cortex has control over the spinal cord and helps to inhibit hyperreflexia. So we all have reflexes, that's normal. The cortex, one of the cortex's job is to make sure that those reflexes don't get out of control or out of check. So there's always this kind of tonic inhibition to reflexes from the cortex down to the spinal cord. So if the cortex is damaged, you lose that inhibition to the spinal cord, and those spinal cord reflexes go unchecked, and therefore hyperreflexia results. So you would have brisk tendon reflexes, you may have the Babinski present, clonus, and spasticity is a form of hyperreflexia as well. So although we don't have a hierarchy control system anymore, and the systems theory tells us that, this is still a proposed explanation as to what causes hyperreflexia. That when the cortex is damaged, you lose inhibition to the spinal cord reflexes, and those reflexes are allowed to therefore go haywire.